Have you ever wondered how we can predict the weather? Welcome to the intriguing world of meteorology. This science is not just about weather forecasts, but it plays a pivotal role in our daily lives. From helping pilots navigate the skies to assisting farmers in planting their crops, meteorology is everywhere. It's about understanding the atmosphere, the meteor, the climate, and the ever-changing weather conditions. And with the aid of advanced sensors and instruments, meteorologists make it all possible. Let's dive in and learn more about this fascinating field. Meteorology isn't just about weather forecasts. It's a dynamic field of science dedicated to understanding the atmosphere's physics and its effect on our planet's environmental systems. Meteorology is where we study the changes in temperature, air pressure, water vapor, and the circulation of wind in the Earth's atmosphere. This science stretches far beyond the daily weather updates. Meteorologists engage in a broad range of tasks, from predicting severe weather conditions to analyzing climate patterns over centuries. They help us understand the world we live in, from why we have different seasons to the impact of climate change on our daily lives. In addition, meteorology also plays a critical role in sectors such as agriculture, aviation, shipping, and even sports, to name a few. It provides essential data that help these sectors operate safely and efficiently. So meteorology is a science that is not only intriguing, but also essential to our everyday lives. The terms meteor, climate, and weather conditions often get confused. Let's take a moment to distinguish between these three key components of meteorology. First up, the term meteor. No, we're not talking about those bright streaks in the night sky, but rather a term used in meteorology to describe any atmospheric phenomena. This includes everything from rain and snow to wind and clouds. And yes, even those celestial shooting stars. Next, we have climate. Climate refers to the long-term patterns of weather in a specific area. It's the big picture view of weather patterns spanning years or even decades. For instance, if we say that a region has a tropical climate, it means that the area typically experiences high temperatures and a significant amount of rainfall throughout the year. Now, onto weather conditions. This term refers to the short-term state of the atmosphere at any given time or place. It's what you experience when you step outside your door. Is it sunny, rainy, windy, or snowy? Those are your weather conditions. Now, you might be wondering, how are these three terms interconnected? Well, meteors, or atmospheric phenomena, are the building blocks of weather conditions. These conditions, observed over a long period of time, shape the climate of an area. Essentially, meteors form the weather, and weather over time forms the climate. For example, if an area frequently experiences thunderstorms, a meteor, it will have rainy weather conditions. If this pattern continues over a long period, the area would be described as having a wet or humid climate. In the grand scheme of things, understanding the relationship between meteors, weather conditions, and climate is crucial in predicting weather patterns and preparing for natural disasters. Meteorologists use this knowledge to warn us about upcoming storms, help farmers plan their crop cycles, and even aid in combating climate change. Understanding these terms is essential to grasp the basics of meteorology. Ever wondered how meteorologists measure weather conditions? Well, the answer to that lies in the wide array of sensors and instruments they use. These tools can be as simple as a thermometer or as complex as a Doppler radar, but they all have one thing in common: they help us understand the weather. Let's start with the basics. A thermometer is a simple instrument that measures temperature. It's a crucial part of any meteorologist's toolkit, as temperature plays a key role in weather patterns. Thermometers work by using materials that expand or contract when heated or cooled. This change is then translated into a temperature reading. Next, we have the barometer, which measures atmospheric pressure. Changes in pressure can indicate incoming weather systems. So, keeping an eye on the barometer can give meteorologists a heads up about potential storms. Barometers work by balancing the weight of the air above with the pressure from the air below. Then we have the hygrometer, an instrument that measures humidity. It's important to monitor humidity because it can affect temperature perception and influence weather conditions. Some hygrometers use hair, which lengthens or shortens based on the moisture in the air. These changes are then translated into a humidity percentage. Rain gauges are straightforward, they measure the amount of rainfall. This is important for tracking precipitation levels and understanding the water cycle. Rain gauges operate on a simple principle. The rain falls into a cylinder and the amount is read off a marked scale. Finally, we have the anemometer and the wind vane, which measure wind speed and direction respectively. Wind can significantly affect weather patterns, so these tools are crucial for meteorologists. Anemometers work by having the wind push against cups or propellers, and wind vanes pivot to align with the wind direction. These are just a few examples of the sensors and instruments meteorologists use. There are many others, each with its own purpose and method of operation. These tools help meteorologists collect the data they need to understand and predict our weather. These tools are the backbone of meteorological studies and weather forecasting. Meteorology isn't just about knowing whether to carry an umbrella. It plays a crucial role in the very backbone of global transportation, aviation. Aeronautical meteorology is a specialized field that focuses on the atmosphere and weather phenomena, specifically as they relate to air travel. It's a discipline that pilots, air traffic controllers, and flight planners can't do without. This is because weather conditions greatly impact flight safety, efficiency, and overall airline operations. Have you ever wondered why your flight was delayed or diverted? It's often down to weather conditions. High winds, reduced visibility due to fog, heavy rain, thunderstorms, or even volcanic ash clouds can all pose significant risks to aircraft. Therefore, accurate and timely weather information is vital in the decision-making process for flight departures, routes, and landings. This is where aeronautical meteorologists come in. They provide essential weather forecasts, advisories, and warnings to pilots both before and during flights. They analyze weather data collected from various sources, including weather balloons, radar, and satellites, and use sophisticated computer models to predict weather patterns and conditions. But it's not just about avoiding bad weather. Aeronautical meteorology also helps ensure efficient flights. For instance, understanding wind patterns at different altitudes can help pilots choose the most fuel-efficient flight paths. Tailwinds can significantly increase an aircraft's speed, saving time and fuel, while headwinds can slow a plane down, requiring more fuel and time. Meteorological information is also crucial during takeoff and landing. Conditions such as crosswinds, air temperature, and air pressure all influence aircraft performance. For example, hotter temperatures can reduce engine performance and require longer runways for takeoff. In short, aeronautical meteorology is a scientific guardian angel for aviation, using data and forecasts to guide decisions that ensure our flights are as safe and efficient as possible. It's an unseen yet essential part of every flight, playing a vital role in the background. So the next time you're on a flight, remember that meteorology is keeping you safe. Meteorology is a global effort. Indeed, it's a collective endeavor that involves numerous institutions worldwide, each playing a unique role in the grand scheme of understanding our Earth's weather and climate. Let's start with the World Meteorological Organization, simply known as the WMO. This United Nations agency is responsible for promoting international cooperation in meteorology, climatology, hydrology, and related fields. From setting global standards to coordinating research, the WMO's contributions are foundational to our understanding of the atmosphere. Next, we have the National Oceanic and Atmospheric Administration, or NOAA, from the United States. NOAA's mission spans from the bottom of the sea to the surface of the sun, but it's their weather predictions and climate research that directly impact our day-to-day lives. Their sophisticated weather models and hurricane tracking systems are invaluable tools in weather forecasting. Now, let's fly over to Europe, where the European Center for Medium-Range Weather Forecasts, or ECMWF, resides. As the name suggests, this institution focuses on medium-range weather forecasting, providing data for the next 1 to 2 weeks. Their work gives us a heads up about upcoming weather, allowing for early preparations. Meanwhile, in Japan, we have the Japan Meteorological Agency. This institution not only forecasts weather, but also monitors earthquakes and tsunamis. Given Japan's vulnerability to natural disasters, its work is crucial for the safety of its people. Lastly, we have the Australian Bureau of Meteorology, or BOM. BOM provides weather forecasts, warnings, and observations for Australia. Its work is particularly important given Australia's diverse climate zones, from tropical monsoons to temperate conditions. These are just a few examples of the numerous meteorological institutions worldwide. Each one, with its unique focus and capabilities, contributes to a global understanding of weather patterns and climate change. Their work is essential in predicting weather, preparing for natural disasters, and researching climate change. These institutions play a vital role in understanding our planet's climate and weather patterns. So the next time you check the weather forecast or read about climate change, remember the collective global effort that makes it all possible. And so that's a wrap on our whirlwind tour of meteorology. We've journeyed from the basics, understanding what meteorology really is, to exploring meteors, climate, and weather conditions. We've delved into the intricate sensors and instruments that make meteorology possible and soared into the skies with aeronautical meteorology. Finally, we've recognized the institutions that make all this knowledge accessible to us. Understanding these elements helps us appreciate the world around us more deeply. Remember, every time you check a weather app or see a weather report, it's all thanks to the fascinating field of meteorology.